Hey guys, how's it going? I've been watching how you're doing on the homework, and I've noticed that quite a few of you are struggling a bit with Newton's third law. So I thought I'd put a video together trying to explain the basic idea. So Newton's third law, so let's run through all the laws. Newton's first law tells you basically objects are lazy. If there's no force exerted on an object, then if it starts out at rest, it stays at rest forever. And if it starts out moving, it will continue to move in a straight line with a constant speed. So it'll have a constant velocity. The second law says that the net force gives you the mass times the acceleration. So those are the first two, and we've used them lots and lots. And I think most of you are getting a handle on how that works. You draw the free body diagram, you choose a coordinate system, write your forces in terms of that coordinate system, and do the trigonometry. And afterwards, you set up find F net in the x direction and then the y direction, get a formula for that, set it equal to the mass times acceleration, and then solve the algebraic problem. Just one second. All right, so sorry for that. So Newton's second law, we know how to handle. But thus far, we basically have solved one object at a time. And so we need some way to put things together. It's kind of like playing Legos. How do you go from understanding what one object will do to understanding how all objects will interact? That's where the third law comes in. The third law is the law that tells us how to connect things up. And if you want, it tells us how to go from studying one thing to studying the whole universe. So Newton's third law says that for every force on an object, there's an equal and opposite reaction force. And we mentioned this before in class. I don't like that particular way of saying it. I know that everyone remembers it, but I always get confused because I think to myself, well, which one's the action force and which one's the reaction force? And I can never remember. Here's the idea. Every force has some object which creates it, is responsible for its existence, and every force has some object which experiences that force. So what Newton's third law really tells you is that for every force, say, of A acting on B, kind of imagine. Let's imagine we have two objects here. We will label them A and B. And so what Newton's third law says is that for every force of A acting on B, there is another force called, I suppose if we call this the action force, and the other force is the reaction force. But either way, I'll just call them conjugate forces because they're related. For every force of A on B, there's another force which is exactly the same in all ways, except its origin comes from B and it acts on A. And it's of equal magnitude but opposite direction. So, notationally, what that means is that for every force A on B, there is another force, which is the force of B acting on A. They have the same magnitude, but opposite directions. And we've seen that a minus sign on a vector flips the direction. Okay, so this is Newton's third law written out in the notation that we have used. So for every force of A on B, there's a reaction force of B on A. So, comments. Remember I said it's exactly the same. The only thing that's different between these two conjugate forces is the label. That means they can't change flavor. So the reaction, the conjugate force to a normal force is another normal force. The conjugate to a weight is another weight. The conjugate to a tension is a tension. The conjugate to a spring force is another spring force. The conjugate, okay. So action-reaction pairs have the same flavor. They're the same type of force. It's just swapping the label of source and observer. So I'm going to go through an example. One of the mistakes that people make is say, oh, if two forces have the same magnitude and opposite direction, then they are conjugate pairs. That's not right. They are only conjugate pairs if they have the same type of force and have the label swapped. So don't make that mistake. So let's get it's people struggle with this one because when we perceive the world, we have a one-sided view, right? We only know about when we push on something. Think about it. Let's see here. So I'll have my assistant come over here. James, go ahead. So in this situation, James, why are you pushing on me?
Dad, why are you pushing on me?
I'm telling you, I can feel you pushing on me.
I can feel you pushing on me.
All right. So you get the point. We only have a one-sided view of the world. We only feel the forces which are acting on us. We don't experience the forces that we exert on other things. That's part of the reason why this can be confusing. So for every force, there's an equal and opposite force which acts the other way. Just a comment on the sapling problems. Here's the deal. There's a question where you've got some weird story about a car pulling a trailer and a trailer, I don't know. One you answer it from the point of view of the trailer, and one you answer it from the point of view of the car. And excuse me. The key is the first label is the source, and the second label is the observer, the one who feels the force. So if it says the force blah 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 acts on something, then that must be the observer. That's the one who experiences the force. And so that's going to be the key to answering the sapling question. So it's really less about physics, it's more about grammar. Just watch the prepositions. You guys all remember the prepositions? I know this is physics, but you're supposed to know that stuff. All right. With on, for, after, at, by, end, against, instead of, near, between, by, off, from, under, down, below, through, over, up, according to, across, abroad, around, behind, before, within, without. No? All right. Not English majors. Okay. Anyway. Look for the prepositions. If it says it acts on something, then that tells you that target object is the observer. If the force is by something, then that object is the source. Okay? All right. I'm going to do another video with normal forces and weights to kind of help hopefully disentangle some of these concepts. All right. See ya.